So let's dive into a really interesting idea called interface pollution, inspired by a story on tech-reader.blog. It's all about how our best intentions as developers can sometimes backfire and why, especially in Go, clarity is king. Let's get right into it. Here's a question for you. Can good intentions actually lead to bad code? When we try so hard to build something that's super robust and ready for the future, could we actually be making things worse? This whole explainer unpacks that exact idea. All right, so let's set the scene. Just picture this old, quiet library in Lower Manhattan. It's the perfect backdrop for our story about a junior developer named Ethan. He's working on a new metadata indexer. He's smart, he's trying to do everything right, and he's about to make a super common mistake. And this is his whole mindset, right? He proudly tells his senior colleague, hey, I've abstracted all the core stuff into interfaces. He's thinking way ahead, planning for any possible change that might come down the line. I mean, on the surface, that sounds like what a good developer is supposed to do, doesn't it? This is what we call a coder's foresight. Trying to engineer the perfect solution for a future that, a future that might not even exist. So what did he actually do? Well, he built a provider interface, a store interface, and a formatter interface. Each one is like a perfect little blueprint, a contract for how a part of the system should work. It looks super clean, it's all very organized, and it's 100% theoretical at this point. Okay, so this is where things get interesting. Enter Eleanor, a senior engineer. She looks at Ethan's work, and she totally gets what he was trying to do. She praises his intent, for sure, but, with experience comes this sixth sense for the hidden costs of our clever solutions. And that brings us right to the core lesson here, this idea of the hidden weight of abstraction. It's about how our attempts to write clean code can sometimes just create a kind of cognitive fog. Eleanor's metaphor here is just perfect. She calls it a fog. Think about it. When you create an interface before you actually need it, before you have at least two different things that use it, you're not adding clarity. You're just adding a layer that makes it harder to see what the code is really doing right now. Let's just break this down, side by side. On the one hand, you've got Ethan's plan with interfaces. It adds this layer of indirection, which makes the code harder to jump through and understand. It can even be a tiny bit slower. On the other hand, just use a concrete struct. It's direct, it's dead simple to read, and it's fast. You literally lose nothing until the day you actually need a second implementation. So what's the fix? What's the right way to think about this? Well, in Go, there's this core idea, a kind of architect's rule. Accept interfaces, but return structs. And the idea is actually pretty simple when you think about it. When your function returns a concrete type, a struct, you're giving the person using your code everything, all the methods, all the data, the whole shebang. If they need an abstraction for their own specific use case, they can define a small interface for just what they need. It puts the power back in their hand. You see, Ethan thought the gift he was giving was flexibility. But Eleanor reminds him that the best gift you can ever give another developer is clarity. Code that's simple and direct is way more valuable than some complex setup for a future that's just a guess. And then she drives the point home with a perfect metaphor. Just looking around the library they're in, she says, this library wasn't built with shelves for imaginary books. They saw the books they had, and they built the shelves to fit them. Solve the problem in front of you. This really represents a whole different way of thinking. It's about discovery over design. It's about letting your abstractions emerge from the code, not forcing them on it from day one. So here's how you actually do that. It's basically a four-step philosophy. 1, start with concrete types. Just build the thing you need. 2, write your code to solve the problem you have right now. 3, as your project grows, you'll start to discover patterns and common behaviors. They'll just pop out at you. And finally, step 4, that's when you define your small, focused interfaces, only when the need is real. And that problem that Ethan ran into, well, it actually has a name: interface pollution. It's exactly what happens when we jump the gun on abstraction. We end up with a fragmented codebase and that unnecessary fog that just makes everyone's life harder. So back in our story, the light bulb goes off for Ethan. He refactors his code, gets rid of the interfaces he doesn't need, and goes back to simple structs. And the change is immediate. The code just feels lighter. It's clearer, it's easier to read. There's no puzzle to figure out anymore, just a straightforward, high-performance tool. And as the story wraps up, Eleanor leaves Ethan with one last metaphor, a really powerful one that kind of ties this whole lesson together. She tells him, an interface is like a bridge. You build a bridge to cross a river, right? An obstacle, like when you have two different databases that need to act the same way. But building a bridge in the middle of an open field, it's just a lot of work, it gets in the way, and, well, there's no river. And that's really the lesson for all of us, isn't it? Our job is to find the actual rivers in our code, the real demonstrated needs for abstraction. We shouldn't be wasting time and energy building bridges over perfectly flat open fields. So I'll just leave you with this to think about. Take a look at your own projects. Where are you building for a future that isn't here yet? Where are you building unnecessary bridges?